Hi, my name is Zoe, and today we will be doing implicit differentiation. I just learned implicit differentiation actually, so I'm a beginner just like you watching the video. Before we get into the math, let's see why implicit. You probably know differentiation because it's differentiation taking derivatives. But why implicit? Well, we know how to differentiate stuff like y equals f of x. For y equals f of x, y is explicitly defined as a function of x. So differentiating is called explicit differentiation. But what if y is not explicitly defined as a function of x? Like if x squared plus y squared equals 1, or x squared times y squared plus 2y equals 4y. So for today, we will be doing the implicit equation x squared plus times y squared plus x sine of y equals 4. The reason it's implicit is because y is implicitly defined. With x, it's like y squared, not just y equals on the side. It's detailed into x squared times y squared, so plus x sine of y equals 4. There's a kind of detail to it. Let's start on the first term, x squared times y squared. That's a product rule because they're being multiplied. Okay, so let's have a prediction of what the derivative of x squared times y squared is. So we know the product rule, f prime g plus g prime f. So let's sort of keep this in the back of our minds. So the derivative of x squared is 2x. And we can have y squared g plus x squared f times y squared prime, which we don't know, so let's add a question mark. Good job. So let's see if we got the right answer for the product rule. We did! 2x times y squared plus x squared times whatever the derivative of y squared is. Great job, everyone! So here's the power rule for y instead of x. The derivative of y to the n equals ny to the n minus 1 times y prime. Here's my little explanation. If you think of y as a function of x, it's just a pause and try. And you can use the power rule for y as a little tip. Chain rule. Okay, so it has to be 2x times y squared plus x squared times 2y times y prime. Because that's the derivative of y squared. Let's go to this term. It's going to be a product rule. So it's sine, the derivative of x is 1, so we can ignore it. So it's going to be sine of y plus x times whatever the derivative of sine of y is. Let's find out. The derivative of f of y equals f of y times f prime of y. You probably notice it's the chain rule, right? Even if you don't, that's okay. It's the chain rule. Okay, so the derivative must be sine of y plus x cosine of y times y prime. Because the derivative of sine of x is cosine of x. So it's cosine of y times y prime. Okay, so now we can add them using the sum rule, and it equals 0 because the derivative of 4 is 0. Okay, let's say we want to find y prime. Here's the procedure. Let's isolate the y primes on the left-hand side and the non-y primes on the right-hand side. So using our algebra skills, we have to subtract these other terms. Let's factor out the y prime and put the factored form as the denominator of both sides. Look, the x squared times 2y plus x cosine of y cancels, so we just have y prime on the left. And we're done. Let's look at the graph of the function we differentiated. Here's the graph of x squared times y squared plus x sine of y equals 4. And what's very interesting, here's the implicit differentiation method, or IDM. So it has two basic steps with some smaller steps. So the two big steps are the implicit differentiation and the algebra. The implicit differentiation is kind of simple. We do the derivative rules necessary for x and derivative rules necessary for y. The derivative rules necessary for x are just to take the usual derivative for functions with only x. And the derivative rules for y would be stuff for functions of y that take the usual derivative but multiply by y prime. And then it comes the algebra. Step 1 is we put the y prime side equal to the x side and y side. And we put the y prime side with a factor multiplied by a factor over a factor and set it equal to the x and y side over a factor. Then we cancel them out and do y prime equals x and y side over a factor. And that's the whole process. And shout out to James Stewart for making the textbook where this problem came from.